Hoy nos acompaña Jeff Félix. Él es presidente de Cernexus, es responsable de promover la misión de la empresa, de cerrar la brecha de habilidades tecnológicas emergentes y cuenta con 25 años de experiencia en la industria de la capacitación y la certificación, sirviendo en roles de dirección general y liderazgo. Hello, Jeff. It's a pleasure to greet you again. Welcome to this webinar. Please go ahead with your presentation.
Gracias. Thank you, Omar. And thank you everyone for your time today. I'm going to start by thanking everyone for permitting me to present this webinar in English. My Spanish, despite my years of study, is not good enough to present, so I do appreciate you accommodating my deficiency with the Spanish language. I actually, if you saw the initial advertisement, it was for my colleague, Jedi John O'Keefe. John had a family emergency, so is not able to present today, so I'm stepping in for him. But also very familiar with this topic. And what we're going to focus on today is the next 10 years and how emerging technologies are transforming our workplace and changing the workforce itself. So again, my name is Jeff Felice, and I serve as the president for CertNexus. If you're not familiar with CertNexus, we're a global certification body focused on vendor-neutral emerging technologies, and we'll define what emerging technologies are today. We're very thankful for our authorized training partner, Proyectum, who is our premier partner throughout Central and South America, and Mexico as well. And so we are very thankful for them for the platform today to talk about these technologies and again, the impact it's having on our workplace and workforce. We at CertNexus have worked with organizations through our partners like Proyectum throughout the world. And these are just some companies where our exam candidates represent across, as you'll see, all industries, as well as public sectors as well. So what are we going to discuss today? Well, we're going to start by first defining emerging technology and some related trends. Then we're going to review the basics of artificial intelligence, data science, and the Internet of Things. And then we'll discuss how these emerging technologies are changing the workforce and how we can continue to invest and generate new skills that are going to enable us to be not only survive, but thrive in our ever more digital landscape. And then we'll have questions at the end as well. But please, as you have questions throughout the presentation, please add those to the chat or Q&A. Omar and I will facilitate those throughout or at the end of the presentation as well. So let's get started. And let's start again by defining emerging tech and the trends associated with emerging technologies. But first, we need to define emerging tech. So what are emerging technologies? And these are technologies that have yet to reach their full potential. So let's take artificial intelligence as an example. All of us today have probably used artificial intelligence. If you performed a search on Google, Bing, or another major search engine, you used artificial intelligence. If you were typing an email and had autocomplete, whether in Gmail or Outlook, or even when you're typing a text on your phone and had it autocomplete, that's using artificial intelligence. If you used a streaming service, YouTube, or maybe another Netflix, or a maybe audio service like Spotify, they all use artificial intelligence for their recommendation engines. Potentially an online commerce shopping experience, where not only do they use recommendation engines, but dynamic pricing, all part that is fueled by artificial intelligence. In many other ways, we engage in artificial intelligence each and every day. So it is a technology that is ubiquitous, is being used widely across all industries and in our personal lives. Yet artificial intelligence is still very nascent. It has so much growth, so much opportunity that it's still classified as an emerging technology, as many of these other technologies are, such as the Internet of Things. Even many mobile technologies still have yet to reach their full potential. We see this in cybersecurity, in 3D printing, in future technologies like quantum computing. technologies we've yet to fully realize and be able to implement in any scale. So again, when you think about emerging technologies, these might not be just futuristic technologies like quantum computing, but technologies we're using today that have yet to realize their full potential. And these emerging technologies are being utilized to, again, transform our workplaces and in many cases, our individual lives. So what are some of the major trends that are being fueled by emerging tech? Well, the first is digital transformation. And you may be familiar with digital transformation. This is where we're starting to replace older digital technologies or potentially even non-digital technologies, things that we've done manually or mechanically with digital technologies. And we're seeing this in many workplaces. And in many cases, we're looking for these digital technologies to help automate processes. So things like data entry, also assembly, and even in manufacturing settings, et cetera. We're starting to see digital transformation happening, and more people are using digital technologies. Think about it, 10 years ago, major carriers that are make deliveries did not use digital technologies. Now many of those drivers and delivery personnel are using digital technologies to scan, to track, to gain signatures, et cetera, for the packages they deliver. That's a form of digital transformation, as well as we see in our office workplaces. The second major trend is the fourth industrial revolution. And this is the fusion of our physical and digital worlds. So think about this. In many of our physical industries, such as energy, manufacturing, agriculture, again, transportation, this is where in the past we've used mechanical devices to operate machinery, as well as to help us determine when it's due for maintenance. Well, today we're doing that through technologies like the Internet of Things, where we apply a device to a piece of equipment or to a truck or to some other, something else physical in our environment. And we're using it to analyze that piece of equipment, that delivery vehicle. We're using it to actuate it, to maybe change the environment as well. And what this allows us to do is better utilize the equipment and the other resources available to us. And it also allows us to ensure better maintenance, less downtime, and overall greater productivity. So again, we're doing this in all fields, right? Whether in physical fields like in agriculture, but again, in energy, manufacturing, transportation, in many other industries where we're starting again to utilize technologies like the Internet of Things combined with cloud computing, data analytics, and automation to again further our industry. And finally, we're also now well immersed in the data economy, and some refer to it as the data and AI economy. But if you think about 10 years or 15 years ago, some of the most valuable companies were companies based in either energy or in they were multinational manufacturers. Today, the majority of the most valuable companies in the world are built on data, and in fact, tying human behavior to data. So let's take Google, for example. I shared earlier that Google uses artificial intelligence, but Google's entire business model is built on data. The majority of their revenues comes from Google Ads. Well, how do Google Ads work? Well, first Google goes out and they index data from the internet. Then people search against that indexed data in a database. They get results back. And with those results, we see ads. Companies pay for those ads to display. But all of that is data. It's the data that Google is actually first indexed from the internet. It's data that they've actually captured so they understand more information about us and our search histories, me as an individual or me or other people like me, and then the ability to dynamically display ads that may be of interest to me based on my search and the various search results. Now, Again, there's a lot of other technologies involved. Google's hosted in the cloud. They're using artificial intelligence and a host of other technologies as well. But again, at the core of that is data. Social media companies are all built on data, right? They bring individuals together to share information, but how they monetize is all through that data, right? Much of that through ad revenue. But even companies like Apple, right? We think of Apple and we think of it as a device company, right? They produce workstations, laptops, tablets, and phones, and watches, amongst other devices. But if you think about Apple, they're shifting now to be more of a data-driven company. You think about the Apple Watch. Apple is now one of the largest aggregators of health data globally. And they're starting to utilize that data. In fact, Apple just recently announced that they're likely to start presenting ads in their various platforms. Again, leveraging the data that they have. And again, many other companies are leveraging this data for other insights that help drive their company. They're using it for artificial intelligence and many other uses. But again, we're essentially generating value from the data that we've been gathering over time. So before we go on to artificial intelligence, just to recap, we talked about emerging technologies and how emerging technologies are technologies that we may be using today, but have yet to realize their full potential. We're then talked about how those emerging technologies are fueling major trends like digital transformation, the fourth industrial revolution, and the data economy. And again, these are all starting to transform, again, our workplaces and our personal lives. And now what we're going to do is we're just going to go quickly through, I won't say quickly, but we're going to just at a high level talk about each of three major technologies that, again, are advancing these trends, being artificial intelligence, data science, and IoT. We'll learn more later that there's actually complete classes on these technologies, but today's just an introduction so we can walk away with some information about each. So let's talk about artificial intelligence first. There's a progression of artificial intelligence being that there's several different types, or not types, but I guess states of artificial intelligence. The first is where we are right now, which is artificial narrow intelligence. So even the most advanced artificial intelligence today can typically only do one thing well. There's now one artificial intelligence that can do multiple things, but even the most advanced ones that, for example, if you want to look on the internet, you can look at DALL-E, which is D-A-L-L-E, can generate images from text. But it can generate images from text, but it can't translate text. It can't understand language like Siri would be able to do. Then we have very advanced deep learning algorithms and networks that are able to understand language, but can't generate an image. So this is what we call artificial narrow intelligence, the ability to have intelligence, but it's intelligence less than human intelligence. And typically today we see that these advanced neural networks are able to do one thing very well. There's one now from DeepMind, which is part of Alphabet, which is Google's parent company. They now can learn and do other things. It's called Gato. Cat in English, but Gato, as you'll be familiar with. So if you want to look up Google or DeepMind Gato, you can see everything that it's learning to do. But yet we haven't with artificial intelligence seen a machine able to replicate human intelligence. And that's what we would call general intelligence. Some say we would be able to do this in the next 5 to 10 years. So a machine will be able to replicate much of the intelligence that we have as humans. And super intelligence is the ability for a machine to have greater intelligence than humans. And some say we may never get there. Many say we probably don't ever want to get there. But again, regardless, we're not even close to having super intelligence in machines. Right now we have narrow intelligence, also called artificial narrow intelligence or ANI, and moving towards general intelligence. We have two types of artificial intelligence. And if you want to think about artificial intelligence first, if we define that first, artificial intelligence is the ability for a machine to complete human tasks. That's really the base definition of artificial intelligence. And artificial intelligence is this umbrella concept, as we'll see in the next slide. And there's two types of artificial intelligence. One is machine learning, and this is our algorithms that we use to be able to essentially create statistical models and analyze and draw inferences from data. And so we'll see how this works in the next slide. But essentially what we're doing is we're taking an algorithm, and unlike algorithms of the past were, and I'm going to simplify, but say nested if-then statements. So if I selected a cell in Microsoft Excel, it would bold. If I typed 123, 123 would display, right? So if this, then that, right? If I select a cell, then bold. If I type 1 through 2, 3, display 1, 2, 3. Well, machine algorithms, learning algorithms don't work that way. The way they work is we actually present it with data, and he uses that data to make predictions. And then it learns from that data. So again, it's different than traditional algorithms. And deep learning is another type of artificial intelligence, in fact, a subset of machine learning, which we do the same thing where we're taking data and allow it to move through algorithms. But in this case, we're doing it through multiple layers, what we call neural networks. And as we'll learn, we actually use this deep learning for our most complex problem solving. They typically require large data sets to be able to learn and make their predictive outcomes. So here's a picture view of artificial intelligence. Again, artificial intelligence, again, that technology concept or essentially umbrella concept, which is, again, the ability for machines to mimic human behaviors or complete human tasks. We have machine learning, which again is a subset of AI, which again, we're using statistical methods to enable machines to essentially make decisions. And then we have deep learning, which is again, we're using these multiple layers of neural networks to be able to, again, make more complex decision-making. So how does machine learning work? Well, again, first thing we're going to do is we're going to figure out what problem we're trying to solve. And we have different types of algorithms that help us solve different types of problems. We have those that classify information, cluster information, and do a variety of other things. And once we've selected that algorithm, we take a training set of data and we run that data through the algorithm. The algorithm is going to make predictions. It will then evaluate the predictions. And again, this is where the big change is from traditional programming, is it will learn from those predictions and improve. And then as we put more data through it, after we've trained it, it will start to essentially make predictions based on that data. And again, the algorithm will continue to improve over time. Even though we've already trained it, it just continues to learn as we present it more data. So algorithms with the right data can actually get better at predicting outcomes as we present it with data and as we continue to monitor it. But again, the big difference here is that the algorithm is not only making predictions, which we can do with other algorithms, but it's evaluating, learning, and improving from them. Deep learning, again, is a type of artificial intelligence and a subset of machine learning. But now we're doing more complex analysis. Again, we use deep learning in a lot in doing with images, computer vision, natural language processing. We use it with more complex robotics, etc. And so with this technology, we do things in layers. So you think about it, I have an image. That image is going to go through an initial layer and say, hey, this image is made up of shapes. It's made up of a crescent moon, a triangle, a rhombus, an ellipsis. Then it's going to start to say, hey, these shapes look like components of a face. It's a mouth, it's an eyes, it's a nose, it's an ear. And then it's going to assemble it together and say, hey, this is actually is a face. And then it makes a prediction. Is it a face of a rabbit or is it a face of a human? Well, it's a face of a human and it's made a correct prediction. So again, what we've done with deep learning is we have a more advanced neural network that is processing information in layer. It's typically processing a lot more information. And as we'll learn, it processes that information typically more independently than we do in machine learning. So when would we use machine learning versus deep learning? Well, machine learning is the most often used type of artificial intelligence today. The reason for that is it's less expensive. It takes less computational power, right? Less GPUs or graphical processing units to do that, or even CPUs. It takes less data to be able to operate machine learning. And typically we have more people that are skilled in machine learning than deep learning. We use machine learning when we have fewer data sets. We know more about our data. We can classify the data. So for example, if we're using a health sample, we know people's weight, their height, their blood pressure, and other physical measures, which we call features. With deep learning, we may know less about our data. We may just say, here's a lot of data, and you algorithm, you deep learning, tell me, inform me about that data. We also in machine learning will have more guided predictions. So we typically will say, hey, with that height, weight, and blood pressure, we want to get to determine whether people have good or poor heart health. In deep learning, we want the algorithm to tell us what these, when we start to categorize and cluster and look at and analyze this information, what comes up, what information, what types of predictions could be possible. And so we'll see machine learning, we can solve really complex problems really quickly with it, but our most advanced or complex problems are solved by deep learning. So again, this is a really high level overview of artificial intelligence to give you a sense of it. There's a lot more here for each type of AI and machine learning and deep learning. There's various approaches that we use. So in machine learning, supervised or unsupervised learning or reinforcement learning. In deep learning, there's different types of artificial neural networks. We talk about how we can use these conceptually. So how are they used in search engines or robotics or natural language processing? What are some of the benefits and challenges of using these in business, and how do we apply them for business use? And as we'll learn, we can see that really everyone in the organization, whether you're a leader, a product or project manager, someone in marketing and sales, will all benefit from having this knowledge, because as we employ artificial intelligence, we need to understand what it can do and what it can't do. How do we get to the best outcomes? What are the data that we need to do that? And speaking of data, that's what we're going to talk about next, is data science. And we're going to just talk about the basics like we did with artificial intelligence. Again, there's a lot more information there, but just talk about the general terminology around data science. So let's first define data science. What is data science? It's a discipline that involves our accumulation of data, our ability to analyze that data, extract value, and present value from the data in a meaningful way. And it really is an umbrella term encompassing a number of areas of data, including analytics, data mining, we use machine learning, and even big data. To put it in a broader context, if you think about it, in a company, we typically have a number of sources of data. There was actually a report done, a survey done by IDC, and they went out and surveyed some of the largest companies in the world. And on average, these large enterprises had 400 sources of data. And 1 out of 5, so 20%, had as many as 1,000 sources of data. So you think, well, that's a lot of sources of data. But you think about it, even in a small company, you can easily get to 10 sources of data, right? You'll have a website, right? That website generates data, right? You can see that data through Google Analytics. You may use Google Ads, and you have a whole bunch of other data that comes through Google Ads. You may have a marketing automation platform like HubSpot. or Pardot or other like platforms. You may have a customer relationship management system. You may have a project management system. You may have an e-commerce platform, a financial system, a human resource or talent management system, and so many more. So you can think about it, even in the smallest of companies, you can easily get to 10 sources of data. Well, think about, and that's not even including social media. Think about, myself, Jeff Felice, if I'm a customer to your organization. Well, you want to see me as more holistically, right? Because I may be interacting with you in Google Ads. I may be engaging on your website. I may be engaging with you in social media. I may also be engaged with you and be an existing customer and purchase through your e-commerce platform, right? Or be in your customer relationship management system. So with that, what a data scientist is going to do is take all that data from those disparate sources of data and start to bring that together so we can look at Jeff Felice as a whole as a customer, potential customer. What products have I purchased or services have I consumed, and what am I likely to purchase based on engaging with you in social media and on your website, white papers I've downloaded, case studies, etc. All of that's possible through data science. And when we look at data analytics specifically within data science, we're starting to look at that raw data to derive insights, right? So data itself is not useful until we can actually start to model it so we can derive insights. Insights are what drive value for our business, right? So anytime we are deploying a data intensive project, we'll look at what's the value we want to deliver to the organization. What are the insights that allow us to derive that value? And what's the data that allows us to derive the insights themselves? So that's what we do here with data analytics. And with data analytics, there's three typical types of analytics that we look at. Traditionally, it's been descriptive, right? It's taking data for sales for the last quarter and describe what's happened, right? So for the last quarter, we saw a growth in sales of X percent. Y products or Z services led that growth, right? We're able to see that because that's all data from the past. We then will use data to start to do predictive analytics. So we say, based on our last 3 years, in a quarter 3, we expect sales to be X. And this is based on performance in the past and maybe some other factors that we're bringing into it. Seasonality. We have a new product launch. Maybe one of our competitors have gone out of business, right? So we can use that type of data to get to predictive. Now what's really exciting is through the use of data science coupled with machine learning and other technologies, we're getting to prescriptive. So not only do we say, hey, this is what's likely to happen in the future, but we can give different options A, B, and C, and say, actually, this is the most likely to happen. This is the most likely outcome. And again, we're able to do this through data science combined with other technologies like machine learning. So we're not only saying, hey, we're likely to grow the business by 7%, but we're able to say, we had options of growing the business by 5, 7, or 9%. We're going to grow it by 7%, and here's why. So again, this is the capabilities we're starting to see through these technologies. And as we learn more about data, we start to understand that data comes in different forms. We have structured data, unstructured data, and semi-structured data. As we would learn in the full course, it actually gets stored in a plethora of different environments. So you can have it stored in data warehouses, data lakes, databases, etc. All do something a little bit different, but again, is where data will reside. But structured data is data that is most easily accessible and which we're probably most familiar with, right? And these typically data reside in relational databases. So databases from Oracle and Microsoft, SQL Server, MySQL, etc. But it's data that comes in and it's structured. So if we look at a person, we can look at their first name, their last name, their email address, their phone number, their street address, city, etc. Right? And it's typically in a very structured format that we can see that. Unstructured data is data that comes to us in again, a number of sources, can contain text or graphics. Think about it, a lot of the data that we see that it initiates through social media is unstructured data. Graphical data, again, and how people engage with us, again, could be unstructured data. And then we have some semi-structured data. This is typically using markup languages like XML or HTML, or using CSV files. If you're familiar with Excel, you can save something out as a CSV file as well. And so this would be considered semi-structured data. But again, as we start to learn about data, we start to better understand, hey, what are the data types? Where does this data live? What types of repositories does it live? And again, we need to understand this so we can start to perform what we call ETL, the ability to extract the information, to transform it, load it, and then we can then start to model it and analyze it. And again, these are just core concepts and principles that we need to learn more about as we, again, start to capture more data and derive more value from data. As we saw, we are now immersed in the data economy, and data is driving a lot of our businesses and our business decisions. So if you look at a picture view of data science, it really, at the center of this, it's really three types of disciplines or skill sets combined. We take people with computer science or IT backgrounds, right? We take people that have math and statistical backgrounds and understanding of business, right? So if I'm someone that has, again, I don't have to be a mathematician. I don't have to have studied math at a university, but I have an understanding for math. I have some IT or programming capabilities, and I understand what our business needs. I'm going to be of great value to that business because I'm going to be able to serve as a data scientist, or if not even a data scientist, maybe someone that's doing more advanced data analytics. And this is, again, where we're seeing, again, the merger of these different disciplines. IT just doesn't sit by itself any longer. It's essentially interspersed throughout the business, and we're starting to see people, again, with different skill sets utilizing IT to perform their jobs. The last technical topic we'll talk about is the Internet of Things. So what is IoT? IoT are things that are connected to the internet, typically through the cloud. In IoT, what we do with these devices is we collect data. That data gets stored in a cloud environment. And we use that data many times for our data analysis. We also may use to actually control remote devices as well. And we're using it for a variety of initiatives around the world, right? In some cases, we're starting to provide security, right? My wife and I were able to build a new home a couple years ago. We have a Ring doorbell. That Ring doorbell is part of the Internet of Things, right? Our doorbell now has a camera on it. So when someone approaches our door, we can see who they are. Are they friend or foe, right? That actually gives us an alert on our phone, on an app. We have the ability to control our heating and cooling, our thermostat, through an app. That is the Internet of Things, right? So we have more and more things, as we'll see, in our home lives. But again, we also are seeing this in industry. We're seeing this when we call smart cities, right? Better control of our traffic lights. We're starting to see this for routing of our transportation, like buses. We're seeing it in our rideshare, right? Whatever you use for rideshare, again, all the rideshare is, again, you're leveraging Internet of Things and other technologies like artificial intelligence, et cetera, and many other industry uses as well. And so some examples of that is if you have a wearable device. So if you have a GPS device you use, or if you have an Apple Watch or some other type of fitness device, those are all Internet of Things. We have our ability now to control our lights, right? I talked about the thermostat we can see on the left-hand side, but we have our lighting in our homes. for some reason, we in our new home, our oven is connected to the internet. I don't know why we don't use it, but I could actually turn on the oven through the internet if I wanted to. But there's a variety of other things, our audio systems, et cetera, in our homes. In industry, again, we're using this to do a number of things. I talked about smart cities, but again, in transportation, as I alluded to earlier, and a variety of other industries, again, we're using the Internet of Things to essentially control our environments, to actuate, to be able to gain information from that. IoT is one of the largest generators of data in the world, right? You think about even just your, if you have a fitness device, I have one on right now, it's generating data all day long that I can view in a dashboard, but again, trapping a lot of that information. And what we need to understand is that IoT is a system of systems. We'll have a variety of items. We have IoT devices, which are sensing their environment. We're able to communicate with that environment. We have the cloud. We're essentially collecting data and storing data and using it to start to perform analytics. And then we have our client applications where we can see, like I talked about, that fitness device where I can see a dashboard view of information. In an industrial setting, it might tell us whether a piece of equipment is overheating. If there's in an agriculture environment, if there's too much acidity in the soil levels, in transportation, whether there's a better route for a truck to take for a delivery, et cetera. Again, all of those being business applications that are deriving information from the cloud that is being, where that data is being generated from a device itself. So with this, in the last few minutes here, we're going to talk about how emerging tech is changing the workforce. So the first thing is, many of us have this fear that we're going to be replaced by machines. And the fact is that some jobs will be replaced by machines, but it's no different than previous industrial revolutions, right? I use agriculture as a great example. If we look at agriculture, we have fewer people in agriculture than we did 50 years ago, and in 50 years ago, we had fewer than we did 100 years ago. With that said, we have more people employed than we ever have before. So those people are doing different jobs, right? They're involved in office work. They're now, in digital marketing. They're data analysts, machine learning engineers, product and project managers, business leaders, business founders, et cetera, right? So the fact is, and the reality is that most of us are going to learn to work with machines, whether this is in a physical environment with robots, as we see here on an Amazon distribution warehouse floor, where essentially the robots are going up and down the aisles and individuals are putting items on it and they're taking it to a packing station. Or we're seeing it again in digital transformation, where we have more software applications that are automating some tasks that are these rote, repeatable tasks that are lower level tasks that aren't, so we can focus on the higher cognitive work, the work that is more meaningful to us and deliver more value to our business. So as we assess this, what we see is that some jobs will, again, be automatable. And you can see in this report from McKinsey, they look at roughly less than 5% of occupations in the digital workplace today are occupations where we can automate them entirely away. The majority of work, we can see roughly 60%, will have at least 30% of your activities that can be automated through the use of data and artificial intelligence, et cetera. Does it mean we're going to work 30% less? That would be fantastic. But typically what happens is we just do different types of work, right? You think about it, I've been in the workplace long enough that we have automated reports that run, right? That used to have to run manually. Well, now we have middleware and other integrations and capabilities where those reports can run, and I get a report in my email each morning that shows me information about sales, about customer satisfaction, et cetera. And those are all automated. It used to be a person that did those or part of a person's job, right? So what we're going to see is, in most cases, most of our jobs, we're going to continue doing the work we're doing, but it's going to change. We will have some jobs that will be automated away. But what we saw, the World Economic Forum predicts that the data and AI economy will create 97 million new jobs and net of 10 to 12 million jobs, plus jobs, more jobs than we have today. So the fact is these technologies are going to create more jobs as other technologies have in the past. I use air conditioning as a great example. Prior to air conditioning, most people couldn't live in warmer places as comfortably, but look at all the air conditioners don't last forever. They have to be maintained. So we have a whole industry of not only manufacturing air conditioners and installing air conditioners, but servicing air conditioners. It's the same thing with any other technology as well. So with that, we have to recognize that we have to have individuals that can not only, from a technical perspective, design, develop, and deploy and maintain and secure these technologies, right? Our IT, our security professionals, our development professionals, other data professionals, right? Those that have the hard skills of doing these things like design and developing solutions. We also have to have all of our business professionals to have the foundational knowledge, some that we just started to touch on today, which is understanding the terminology. Conceptually, how are these technologies used? So conceptually, how does AI work in robotics? How does AI, again, work in search engines? Natural language processing. I know that I can talk to my phone and it understands me, but how does that work? What are some of the benefits of these technologies? What are some of the challenges and how do we apply them for business use? So whether I'm a business leader, I'm a business stakeholder in marketing, sales, operations, supply chain management, or I'm a product or project leader, I need to understand how these technologies work because these are the technologies of the future. But like any technology, they have to be used for the right purpose and they have to be implemented in the correct ways. And so we all need to understand these technologies. So we're doing that and just not deploying technologies for technology's sake. So with that, with our partner Proyectum, one of the things we are offering into the marketplace now is our emerging tech for business professionals, or ET-Biz. And this is a stackable credential that includes our artificial intelligence for business professionals, or AI-Biz, our data science for business professionals, DS-Biz, and IoT for business professionals, IoT-Biz. If you earn all three certifications, you can earn all three separately, or you can go on to take the ET-Biz certification, which gives you the emerging tech for business professionals as well. Again, we just started to touch on some of the knowledge you would touch on these courses, but again, the intent for these courses is for everyone in the organization in non-technical roles or those who are in technical roles and want to learn more about a specific technology. So again, a product or project leader, a consultant, someone from marketing, sales, operations, a business leader, we all need to better understand these technologies. And with that, to summarize, before we open it up for Q&A, what we have to recognize again are emerging technologies are transforming business, our governments, and our personal lives, right? All of us are utilizing these technologies knowingly or unknowingly every day. And we're starting to see more of them as we start to see, again, more personalized search results, more personalization in our streaming services, more personalization in our buying habits, et cetera. Again, emerging tech is remapping the jobs landscape, right? We're going to have fewer data entry professionals. We're going to have more data analysts, more data scientists, more machine learning engineers, more IoT practitioners, right? So we're going to, again, these emerging technologies are creating new jobs or creating a need for us to change the skills or update the skills that we have even in our current jobs. And we need to prepare our organizations and ourselves with skills for the future. So the fact is that for companies not only to survive, but to thrive, they need to be sure they're providing their team members with these skills. And we need to continue to update those skills. When I first started in my work career, technologies used to last longer, right? I could learn a technology and the shelf life, my understanding of that technology would last for multiple years, 3 to 5+ years. Now, Technologies are changing so rapidly. If you're a digital marketing professional and you use Google AdWords, the Google AdWords you use today is so different than the Google AdWords you used 2 years ago. If you're a project management professional, think about the applications you're using today to manage projects. They're vastly different than they were a few years ago. If you're someone that is using a dashboard, whether for analytics or you're a business leader to consume information, dashboards didn't exist the way they do today, right? Using tools like Tableau or Microsoft BI or more advanced tool sets as well. So again, the ability to prepare our organizations and ourselves for the future and continuing to retool ourselves as well. And with that, I want to thank everyone for continuing to stay with us here. And we're going to open it up for any questions that you have.
Thank you, Jeff. Thank you for the presentation. Let's continue now with the question and answer section. Josue Valerio, how the blockchain will contribute to change our workforce?
Yes, thank you, Jose. So yes, so blockchain is going to be another transformative technology. It is another emerging technology. Many people think of blockchain and they think of cryptocurrencies, right? Because blockchain is powering cryptocurrency. But blockchain is being used for so many other purposes as well. We're seeing it used in other data-intensive industries. And the reason for that is that it's a distributed technology. It allows us to do things more securely. One of the biggest challenges we have with all of the data in the digital connectivity that we have today is how do we do that securely? And so many believe that blockchain will help us to solve for that security challenge that we have. So allowing us to have, again, as much data as we do now, even more, and allow it to be more distributed, more equitable potentially, and more secure. Again, those are all things still to be seen, but it is being a technology that's being deployed more and more often.
Thank you, Jeff. Oscar Briceño, can you share with us any recommendations to manage projects that make use of these technologies?
Yeah, so in managing projects associated with these technologies, a couple things. The first is better understanding the technologies themselves. You know, and this is not only goes for project leaders, but also your business stakeholders. I think far too often we think that technology is going to solve our problems, but I always think about it, if I see a screw, I'm not going to use a hammer on a screw. I'm going to use a screwdriver to screw in the screw. It's the same thing with technology, right? Artificial intelligence may not be the right solution. You may need a data scientist, someone that can actually make sense of your data before you try to get to predictive outcomes. So what I would say is, you know, educate yourself. I would also advocate that those who are on the project team are educated. Again, just the foundational understanding of the technology. And then is in regards to managing the project, it really, I will say the most important thing is going to be data. It's going to be the quality of your data, whether it's in data analytics, whether it's in machine learning, IoT, etc. Data is becoming your most important asset, but we need to understand how we're collecting that data, who we're collecting it from, are we doing it in compliance with any regulations? But then is that data fitting for our needs? And there's so I could talk about a half hour easily just on data and the veracity of the data, and et cetera, and so forth. But data is going to be extremely important to any project.
Thank you, Jeff. Lisbeth Peña, Jeff, thanks for sharing these topics with us. How can we prepare to follow this wave of tech disruptions?
Yeah, you know, I look at it as we just need to continuously learn. You know, I think we have to be in the mindset that the knowledge we have today is knowledge we have to build on. And so, you know, as I said, when I started my career in the mid and early 1990s, I could learn something and I could, you know, essentially not have to worry about relearning or topping up that knowledge for months or years. And now, even with regards to artificial intelligence, right? I talked about artificial narrow intelligence. Well, prior to May, there wasn't an artificial intelligence available to us that could do multiple tasks. Now there's one that is able to do that, right? So if I wasn't continuing to look to update my knowledge, I wouldn't have been able to do that. The other thing is understanding that, you know, how tools can help us do the things that that take a lot of time, so we can work on doing higher level activities. So the tool sets are becoming more capable, and we need to better understand how to use those tool sets. And then ultimately, right, is better understand even the methodologies in which we're utilizing these, right? More and more of us are using more agile project management methodologies. Well, how do we take those methodologies combined with the tool sets and the technologies that we're leading projects on? How do we combine all that together?
Okay, Jeff, one more question. So your opinion is that robots are not going to replace project managers?
That is my opinion. In fact, the projections are that we're going to need more project managers than ever before. And the reason for that is that artificial intelligence and robots do not have the cognitive capabilities that humans do, and nor do we expect it anytime soon. So an artificial intelligence can make a decision from a lot of data, but they're very narrow decisions. And as we know with project management, we need to make decisions that take not only multiple inputs, but have multiple dependencies, have multiple stakeholders, etc. And with that, we just don't have AI that can do something that is complex at that. So the fact is that as we deploy more technology, we have more digital transformation, we have more, you know, fusion of our, you know, physical and digital worlds, have more data. We're going to need more people to manage those projects. So I think the good news is for project managers, the outlook is very positive, and we expect to have the need for more project managers than fewer.
Thank you, Jeff. One more question, Hector Perez. Hi, Jeff. Would you say that artificial intelligence is getting more and more being embedded in most software to be in hands of final users, or artificial intelligence will be applied more directly on some particular job roles by organizations with their own artificial intelligence efforts, or a little bit of both?
Yeah, it's you know what, we have the expectation that AI is going to be embedded in everything. It's a matter of time, I think. It's, you know, you think about it today, how many of us work without the internet? I think, you know, in a office environment, it's 0%, right? Almost everyone's on the internet. How many of us are working with mobile technologies, right? Artificial intelligence is going to be that ubiquitous. Essentially, we're all going to be using it in some way. And so, again, we've seen it initially, we're seeing it utilized by some roles in the organizations more so than others. It definitely where there's more data available. So we're seeing it in industries the same way. But if you look at it, every software, I guess, serving every part of the organization, whether it's supply chain management, talent management, whether it's financial management, and so on, all of them are the leading providers, and those that are trying to disrupt those providers are utilizing artificial intelligence today. So I would say the expectation is over, you know, the next 5 to 10 years is that there will be very little software that will not contain some level of artificial intelligence.